So I guess, can you hear me? No. I guess we can start. The mic seems not working. Is it working? Is it working? Seems to be a little bit different from the other room. Try to see if it's okay. Is it okay? Okay. So okay, good. So let us review what we have done before the dinner. I hope you have a good meal. We covered a bit, but I guess if you did a lot of carbohydrate, then you will feel a little bit sleepy. But let us try to quickly review and finish this part because we just left something there. So the main thing is linear regression, right? Just like how to minimize the vertical distance. It's a linear method. And we learn how to make it nonlinear by taking logs, right? And the interpretation is very different. And we also learn how to use the non-parametric method like the beam scatter plot, also the Lewis, right? There's a two way to do other things, right? And I think we stop somewhere here, and then we do the star glacier. So what left is there's two different ways to handle the non-linearity. So this one we call is the piecewise linear spines. And basically it's just like cut your data based on X into multiple parts. And each part you run regression by its own. But the fact that, I mean, it's not separate regression. You have to require the link, okay? In the sense that along the boundary will be related. And mathematics is like this, okay? It's a regression if you forget this one, right? You forget because this is a regression here. If you simply clip this guy, it's standard regression, okay? You forget what it's doing is, if it's less than K1, it will be this one. If more than K1, this is gone, it will be following this one, okay? And so on and so forth, okay? And so the main idea of doing this is you will be ending up, your model will be ending up like this, okay? So it is, you cut at 4, so you will be a line here and a line there. So there's be two different lines. We will have a example, a real world case to show you how we are going to use it, okay? So the example is based on the following study of a cross-country data on life expectancy and average income. Okay, so it's a very standard thing. It's trying to see if people live longer for which country. Okay, so we'll consider. You can do a scatter plot, which we will do, and you will see it's a kind of nonlinear. Okay, you can do a lowest and then do whatever. It's nonlinear. So of course, you can take log, right? But sometimes take log may not solve all the problems. So the other way we do is spine in a contrasted thing, and then the data based on world development indicators. So turn out that you look at the data, later we will see is usually when country get richer, people live longer, right? But when people get sufficiently rich, they try to do various things, right? And say for me, as a professor, as a poor, so I keep drinking water and tea without sugar, right? For people, rich people like some of you and some of your friends, right? Start drinking nice bubble tea or milk tea with sugars, right? Then tend to be less healthy, right? And look at the US, right? People keep drinking Coke, eat burgers, right? All the sort of crazy thing you can imagine, right? Then right, then you will see actually people have a less healthier life and they live less long, right? I mean, probably you know, right? Hong Kong is the one of the population where people live longest, right? But Hong Kong is not one of the richest area, right? But if you look at the place in US or Switzerland, right? They would have more money, but they don't live longer, right? And in general, right, men, on average, men earn more than women, right? But turn out to be women live longer than men, right? So money cannot explain everything, right? Because men would drink, smoke, and do all sorts of crazy things, right? I mean, so that means that, I mean, that we believe in this model is like when the country is rich, we cut at 50, and then you will be there, right? Because look at the data, right? Which we don't, but it's like here. If you look at the data, you will be something like this. But let's look at the data, okay? So the data is coming from the World Bank. It's downloaded from here. So let me copy it and just run together and see if we can do something on that. Let's go to the end. Okay. And let's run this data, right? Because as usual, we want to check whether the data is right or wrong. And then you would do, say, again, do the head thing and see what do you have. And once you're done, then probably you also want to do the describe, right? And then see the summary statistics, right? See what's the mean, average, those kind of stuff. Right? Then see if things make sense, right? But anyway, now the question would be, okay, in the slide, right? What we're going to do is focus on one particular year. Okay, that means that we focus on cross section. Okay, particular year 2017. Here, I want to introduce you another way to express that. It's called the lambda function. So you can do the lambda year equal to that, but you can pretty much do the DF thing. So instead of lambda, we'll do the more usual thing we do, right? So if you don't like this lambda function, we just do that. I think this is the one that more we used to that one. So let's do this more usual thing, but that'll give the same answer. Okay, so this is what we have, right? And once we're done, right, we can do the plotting first, maybe. I don't know. Do you want to do the plotting first? Maybe you plot the graph first, because I think that would be, before we do anything regression, maybe we should do a graph first, right? We do a scatter plot first. Let's call X the, because we want to explain the GDP and the life expectancy, right? So let's do that first. So let's do GDP. This is GDP per capita, right? And then we do this is the X. And Y is how long they live, right? How long they live is the variable, is the life expectancy. Let's do that. Okay. And then that is the reason why this is nonlinear, right? In particular, you would think that somewhere here, then things become different, right? So that's why it's nonlinear, the data. So using regression will not do the good job, right? I think that I should show you this graph before we do the nonlinear thing, right? So what we want to do is to cut off at 50, right? So somewhere here, in fact, right? So you can see what the book is showing is just like you cut at 50 here. So we have two different worlds, right? To be somewhere here and somewhere here. Okay, and instead of the GDP capita, because it's like this shape, they log it first and then make it look nicer. So let's see what the book doing is we first take the log first, okay, and then maybe I draw a graph of log, right? So we take the log instead of this, all right? We do the following. We do log right. Maybe I think this is. I think I changed the notation a little bit because I think that is better. Okay. Do the log y, right? Oh no, I should log x, not y. Sorry. I should do the log x. Okay. I should take a log on x. No, I think the book used this, right? I did log it, right? I took a log already. So I just do the log. Okay. Instead I call, okay. What I do is instead of the x, now I have a log of x, right? Log GDP called x, right? Then I plot the this in log scale. So it will become, you see, much more nicer, right? That's why I take log. But still, you would think that here and here people would behave differently, right? Because as we said, right, which country in fact is not doing well in terms of life expectancy, right? So it means that we need to figure out the linear spine, right? So what we are going to do is using the stat model, okay, and to run the regression, okay. The only thing is the linear spine is there's some way to change the constant. Okay, the way to do is according to this is like we do the same thing, okay, and we create using a function from Ph.D. called BS, okay, it's just called as basis, and we do a spine and then tell them where to cut, okay. It's a little bit convoluted, but let me go step by step. First, I want to have the cutoff at 50. I cut off there, okay? And because the cutoff 50 is based on the non-log scale, I have to log it first. That 50 become a log scale, okay? Here, the x is the log GDP, that's no problem. And I create the basis, which means that I create a new thing, and such that the nox is equally equal to this guy, 50, because you allow more than one. So if you more than one, you have a list there, the same thing, okay? And because the linear spine, the linear regression, then it's like this. You can group degree, then you have more than one, right? And intercept true. So if you worry about it, because what we do is the same, so basically you always keep this guy, right? Only change this one and this one, right? You maybe a list there, but other things are pretty much copying, right? So that's what we do here. So here was what we're doing. Okay. This is, we run this one, right? Once we run it, then we can actually the simple thing run the regression, right? Same as before. So there's nothing new there, right? So the only thing new is this. You add the constant is based on the basis, right? The x1, you transform it, you add a constant back because you always need to add a constant, right? So there's nothing way deep there, right? Basically, you come x, you transform it, you add the constant, then you just run the basic equation, right? So once you run that, right, this is the result. And with R square, so there's nothing very deep there, right? It's R square, and then you have some constant. I don't think you care about this, right? The only thing is you want to look at how the graph looks like, right? The graph will look like this if you try to plot them. Right, this is the, when you plot it, it becomes a graph there. All right, looks like this. So this is how you try to fit and turn out. You expect if you cut at here, people getting richer, they live longer, but when it's too long, then they go down. All right, so that is how you would allow non-linearity. I mean, this linear spine. So the spine thing, I think in economics is less common, but still being used. Okay, but the one I think the most used one is the one that we will cover now. Is called the square. Okay, probably if you recall what you learned in calculus, is any shape of function as long as continuous differentiable, right, can be approximated by a polynomial, right? You say kind of function, then you can always a polynomial can continuous function can be approximated by polynomial. And here we have allowed that to nonlinear. And that's turned out is not something complicated to do in Python. The only troublesome is the interpretation. Okay. And before, if you have a regression, the beta simply means the slope, right? If you increase x by 1, then y increased by beta. But now you have a nonlinear term, then what does that mean? Less clear. The interpretation will be, say, the slope is changing because it's a curve, then it depends on where the x is. Okay, so this is like much more complicated. The slope is keep changing. Later you will see the graph. Let me show you the graph, right? At the end, if you run a this regression, right, and the graph looks like this. Okay, say nonlinear at the end. So it's unclear what it means, but if you just care about the fit, that is what we have. Okay, bless you. So let us actually run the thing. Okay. So we create square. Either use dot power 2 or double dot square, same thing. Okay. So that creates square term. Okay, so it means that we create a new column that has a square term. Okay. Once we did that, then because of now we have actually more than one variable. Okay. And the most convenient way is to use the API formula. Okay. And we can say the formula is y equal to x and x squared. You don't need to write the constant. Okay. So then you fit it and you look at the result. That is what we want to see. Okay. So let's see the regression outcome. Okay. 10 seconds for you to copy and paste if you want to. Okay. But we will talk about multiple regression at the very last section of today, but still we can look at R squared, the same thing. These are the coefficient. Okay. Intercept is usual, but here the intercept do means that the graph looks like this, the square. All right, it's a concave shape. Okay, and right, this is beta 1, right? This is beta 2, This is alpha, right? So this is the thing we need to know. And the next would be, okay, look at the plot, right? So we want to show you the plot, and then you will see what kind of graph we have, right? So this is why I think we already did that, right? So this is the graph, right? It's a kind of concave shape, right? So with the negative lot is an issue, but that is what we have. So you can see already adding square or adding cubic term is already solving a lot of issue there. So for fun, or may not be fun for you, but let's have the following fun. Okay. So now instead of square term with cubic, okay, just for the sake of fun, okay. So you can cubic power 3, right? And then you can add another term, GDP PC cubic, okay, and call it 3, right? And then I don't care about the regression result, but I just want to look at the graph. Okay, so basically just I allow myself to go crazy. Okay, of course you can go as many as you like, right? But maybe I should also view the result, right? Because otherwise it's more fun to see the result as well. So I don't pin the summary result. So same as what you see, right? Because I just add one more formula there. So if we run this, okay. Okay. So the R square, the cubic one is 0.6. It's very strong. It's very good, right? And now we have a little bit improvement, right? And I don't know, this is very small, but anyway, look at this. It become like this. How do you think? Do you think it's reasonable? If not, then just don't use it, right? Because you shouldn't use something that you don't even believe it, right? There must be something without common sense, right? You can just, that makes sense, you can just drop this model, right? So usually you would try to see if there's a non-linearity, you just add square. If okay, then go ahead. Cubic, does it make sense? Still the nice shape, we should follow what we think. If not, then you don't, right? Because we are not machine, right? We look at the result and we make sense of it, because at the end of the day, right, you are not statistician, right? You are IT manager. IT manager have to make business decision, right? This shape is, if you notice, it's called overfitting, right? You fit too much, right? R square is better, but you are relying a small amount of data to allow your thing go crazy, right? So yeah, but that means that I will not tell this to my boss, because he will think I'm crazy. So this one may be okay, right? So that is how you will stop here, maybe, right? Or you can use the spine, right? That would be less crazy, right? This one may be a reasonable one, right? But which one to use, we will talk about that later, okay? But this is the way that we do two variable analysis. Is that okay? So we know how to estimate this, but if there's no problem, then we go directly to how to actually use it in the slide set of the fifth set of slides, right? So I think we can go to the other one. Is that okay? So I think we're done with this set of slides. So as I said, right, you have the visual inspection, which one is good, right? The cubic one is not really good, right? And you need to use economic theory, means that your managerial instinct, right? You have to tell, okay, this is right, this is wrong, right? Cannot just rely on the machine, right? Because now you know ChatGPT often generate hallucination, right? They keep something that's crazy, right? You have to know what to do, right? And there will be some measure to do it. I guess what left is going to talk about is our slide set number 5. Okay. although I think we are behind the schedule a bit, but later I will cut out some chapter I'll cut something that you notice why I cut. But for the moment, we just continue and then we will cut something out. So what we are going to do now is to look at how to use the model, right? Because as we said, what we do is we have a bunch of data, right? We simplify to a line or curve or whatever, several line segment or some simple model, right? And the model actually represent our best guess or point estimate, or just one point, right? But rather, we are not just into the point by itself, right? Remember when we learned estimation 2 weeks ago, right? We want to calculate the standard error plus and minus 2 SE, right? So we want to do it here as well. With regression, we want to tell you the bandwidth, right? So if you try to make sense of it, let's see the following, which you have seen that many times on the TV if you are aware of the Hong Kong typhoon. Okay, and you try to look at the image like this. I hope you know what the image is this, right? Let me get bigger. Can I get bigger? This one, can I get bigger? Why cannot? Oh, this is good. Okay. So you will see, I don't know what this typhoon is, but anyway, suppose a typhoon there, right? There's a map, right? And I hope you know what the circle means, all right? But so this is the typhoon path, predict the path, right? So that this, if you know what it is, it's like this historical path, right? This data, right? And this auto data as well, right? This is why they have the solid line. And probably you know what the dotted line means, right? Dotted line is actually using the supercomputer. They calculate what is the mean path, right? And this is exactly our regression, right? This is the line that on average is what predict. But we know that, well, things changes, right? And it may go the other way, right? Then just give me this line, not sufficient, right? That's why you can see the yellow path. And there will be a 95% confidence that it will be here. Okay. And you see the further away is bigger and bigger and bigger and bigger and bigger, right? Because when you go further and further, there are more random elements. So that's why the range will expand, right? But this is kind of regression model, you can say, right? Because indeed you can have a regression model, right? Looking in the future. But that's the same idea when we do regression, right? Same idea, right? So we will have a maintain the line, but also want to have the bandwidth that we think most likely the data would be around there, right? So that would be what we try to do, okay? And that's a prediction. The second would be we learned hypothesis testing, right? And 2 weeks ago, and that we use that as well. It's because once we estimate the model, we want to know the model is meaningful. It's not by random, right? We want to test hypothesis, whether the slope coefficient we figure out, the beta, is actually different from 0, right? If it happen to be the beta, in fact, has a large fluctuation, right? Because the mean can be meaningful, but on average may not be different from 0. So the model is useless. So you predict the model, it may not be useful, right? So that's why, as I already hinted, right? We will look at the regression table. We look at this thing. Okay, look at this. Okay, and this part of the prediction, what are the number that are available, right? Plus or minus 2xe, and this p or tse, the t value or the p value, is asking whether they are meaningful. Okay, in particular, we focus on the p value. If less than 5%, then we're happy, done. And these are the range of the value, right? Can be the slope, okay? And then don't worry, we'll do slowly, step by step. But these are the procedure that once you do the modeling, then you have to check. Okay. But anyway, I already hinted what I'm doing, so let's go straight forward, right? That is what we're doing. And after that, we'll do multiple linear regression, which you don't have to think because just instead of x and y, you have y explained by x1, x2, x3, x4 up to xn. So it's like more realistic stuff. Okay. So let's get ahead. Okay. So as I said, we need the two things. We need to have a confidence interval, okay, for the width to the slope and the co-intercept, and also the value we predict, okay, and also we do hypothesis testing. Okay, we want to show you the model is useful, and how we predict the thing also will be very useful as well. Okay, so there are two things. First is the confidence interval for the beta, right? It's just plus and minus 2SE. You learned that, right? Just the way we do in this class, always the predict thing is the one you calculate the model, and you plus and minus 2SE, right? That's how we do it, okay? And how do we find the standard error? Luckily, in our current model, it can be done by data, can be done by the formula, right? But again, if you recall, we can do bootstrapping, right? With sampling, right? Because you can imagine, well, but I didn't do it here because the textbook didn't talk about that. But you can imagine on the data, I can bootstrap the data, and I can run regression. Then I have many regression. I have many slope. The distribution of slope will give us this standard error. Do you recall that? Okay. No. Okay, that's fine. So let me recall. Let me go back to very quickly. Although it's not very crucial, but I want to show where was my slide? So if you recall, topic 3. Remember how we do the standard error. The right standard error is you maybe do the bootstrap, right? You got the data, repeat again, right? Look at each time you calculate the sample mean, right? Look at this sample mean, right? Generate the fake data, right? You create parallel universe. Each universe has a mean, right? Then you can come up with standard error, right? That is how we do. So the regression also actually you can do the same, right? Although we don't cover this here, but potentially you can create the data set, many parallel universe. You run the regression many times for each universe, and then you come up with slope for each universe. You can plot a bar chart histogram for the slopes of all the universe, and that gives you the standard error, right? But to be honest, this is not used that often, okay? Because we have formula that give you the nice property. But when you look at other technique, then machine learning, then may have you to rely on this because there's no particular formula to calculate those. Okay, but anyway, for the moment, what we will do is we'll run the regression and showing you this. Okay, and this is the formula is for the standard error. Okay, and this one I think you learned that in the undergraduate, the formula, but I'm not going to bother with that. We have been using this, and in general, this is not sufficient. Usually, what what we do is what we call the robust standard error. Okay, and there's a complicated formula. It's much more complicated than that. If you learn econometrics, they will know it's called, sometimes they call it the white standard error. But for us, it's very simple. We just add one line of code, then we can do. Okay, so actually, if you look at our regression result, okay, look at a simple regression. We've been doing, say, like this one. You will say the covariance type is non-robust. Okay, robust is the so simple one. Okay, and in general, you want the robust version. Okay, for robust version, it's very simple. It's just simply here. When you fit the model, you tell them you want to fit one particular type. We can use HC heteroscatterity. Usually, you can use HC1 or HC3. Okay, and textbook tell you HC1, and I think in economics usually we use HC3. But they are very minor difference, so don't worry about that. So this is the idea of the regression, but I use covariance type HC3. Just input a option there, and when you run it, I'm not going to copy it, but you can try at home. It will tell you that which HC3 is here. Is that okay? Because I want to turn your attention on the following is you want to test whether the slope, right? But before we say it, why this is, okay, sorry, why this is, we need this covariance because the covariance would affect whether you use HC3 or not, will affect this interval. Okay, so let me probably show you this because I guess it's good not to show you this one. Okay, so I copy this guy and run. Okay. Maybe I should show you this one. So I have a regression here, right? If I suppose I run this one without this line, okay? And what we have is this is the value, and the last two columns here, right, represent the confidence level of 95%. Okay, this means this plus 2 times this guy and give you this guy. And minus 2 times the guy should be this guy. Okay, and you will see it's not 2 times because the data is very small, so you need to way more than 2 because it's t. But when in general, when the data is large enough, it's 2 times. The same idea here. So but if you use the HC3, okay, this number will change. Okay, just remind you is 1.9, 1.94. Okay, okay, it become bigger, 2 and 2. So usually we use it because this is more conservative. Okay, that is the standard rule you use is always use the robust version. You can use HC3, or sometimes you can use HC1. And textbook tell you this one. Actually, it's slightly smaller. There's some complication which one to use, but I think we always use HC3. Okay. That is, I think in economics, that's how we do. And if you want to know what's different between HC3, HC, whatever, there are many types, you can check Wikipedia or the ChatGPT. There are many types to do. Okay? But we are not concerning how this differs from that. Okay? We are not worried about that. But you should use the robust standard error. So what we know is this guy already, right? So we know this is the beta will be around this range. Okay. So you can see the beta can be -2 or 2, right? So that means that it includes 0 at the middle, right? So this is a rubbish model, as you expect, right? Because it includes 0, that means that you can't say it's non-rubbish, right? Because 0 is rubbish. So let's change some number, maybe make it less rubbish, right? Suppose I change it to 10. I think it will become a useful model. Still rubbish. So maybe I change to that. Still not very well, but then this one is still rubbish model, okay? Kind of, right? Because this is some really reasonable. This is like 10%, right? But this is a kind of like not very well, still includes 0. Right? So this model is not working very well, right? Because data is a limit. Right? Suppose you change add some number here, and I guess that will become you start to be meaningful. Now it become meaningful, right? Because this value doesn't have 0, right? The confidence interval doesn't include 0, or you consider the t-test, which is here, right? This is less than 5%. This thing is meaningful. So that's why you always need to check this guy, okay? And of course, if doesn't include 0, this guy is good, right? So basically, the only thing you care when we do regression, only 2 things. One, look at this thing, and look at here, the p-value. If less than 5%, then you're done, okay? But of course, you probably want to report what your guess is, right? Because this is, you give me this one, right? You also want to give me this 2 guy, right? Just the same as the data, right? Either you report me the mean and variance, right? That would be a good estimate, right? You can give me this guy and this guy. But sometimes I want you to give me the coefficient and also the confidence interval, right? The confidence will include the standard error anyway. So that would be the things we want to report. Is that clear? Is that clear what we're doing? So, and that's the regression main thing we cover already, okay? So we have that, right? Test coefficient, and then same, we can do the intercept, but the same idea, but I'm not going to go to the models, okay? So after the break, we'll go into a case study looking at how earning wages explained by the gender gap, right? Whether men and women, they make money, their difference, and see if there's a real difference, okay? And we want to run a regression to understand this problem and understand how wages are changing based on your experience, how age, the growth path, run a regression on that, okay? And we will combine this in the, when we talk about multiple regression, okay? So let's a break of 15 minutes. And after we come back, then we look at the case study, okay? So let's break 20 minutes, and then I open the break. Okay, I think we need a 15 minutes break because I guess you're tired a little bit. So let's resume at 7:38. Okay, that's a 15 minutes time. So feel free to ask me question. I'll walk around. So I hope you have a quick break. Because human attention span is a little bit cannot be more than an hour, so we need to have a real break, right? If you don't have break, then we'll die. Let's see. Why? Not working. Okay, let me check how well we are doing. Enjoy the weekend. A bit tired. Yes. So that's why I'm a little bit slowed down a little bit because you are with I get tired. Oh, so it's clear that we are all tired, right? Because I think before the break, we only have Monday, Friday, and Wednesday. But now after the dinner, we also have Tuesday and Thursday. So apparently, your mind has been very confused right now. Um, well, the weather is also very confused because now, and I don't think there's any sun. So you guys will be very confused. Yeah, it's yes. Oh, nothing. That's good. Either we are sleeping or what. The speed is okay, I guess, right? Overall. Yeah. So we start to have someone not following, sleeping, tired. Okay. But don't worry, what we're doing is not something very complicated. Just telling you how to use the table there. Chip, chappy, chappy, chappa, chappa, tapi, tapi, tapa, tapa. What's that? Is it some song? But anyway, let me close this one. Okay, let us look at this particular case study, right? Because that is the way we learn, right? So this is the textbook. Although it may not fit the best for your IT exercise, but learning how to work on it is cool. So we want to look at the wage gender gap. Is whether men and women have different wages. Is it real? So what we do is look at the US data. This is government data. So that means that they follow people, many households. They look at them in 4 months, take a rest for 8 months, and another 4 months. Probably you will ask why they do that. One of the reason why, because people have job turnover. Sometimes they don't have job, right? So you stop a little bit, and then that will be more accurate. Okay. And they look at the weekly earning. And first thing we do is to age restriction. So we want to limit to the people who are actually working, and only include people who actually employ, right? And exclude those self-employment, because self-employment, there's not the gap is not about discrimination, right? So this is the reason why we focus on this data restriction. Okay, and the first thing to do is to normalize by working hour. The reason being that men usually work longer, so the total wage is not good enough. So you have to divide the total earning by number of hours they work. Okay, and look at the raw data. Men actually make 70% more than women. Okay, this is the data. So let's look at the data. This looks like this. Okay, Men on average are making $24 US dollar per month. Women making $20 per month. That's the data US dollar in US in 2014. Okay. So let's look at data. This is what we do. Okay. Let's quickly and run this. I guess at the moment, this one shouldn't be something very complicated. I think we now should be the set of lesson 5. Let's run this one. Okay. This will, the data are there. Okay. And to be usual, we look at data. Okay. Look at first 5 column and see what do we have. Okay, there's a bunch of data there. Whatever, there's a 23 column of data. Okay. Now, the next thing to do is, as we said, we focus on, we have to recode the data. First is the data, you look at the description, turn out to be female is coded at 2, male is 1. Okay, so it's not very convenient. In statistics, usually we will call it dummy variable. We call it female data. Female variable is 1, then it's female. 0 is male. Later you see why, because that is how we run regression. Okay, so this is the regression variable X. Okay, we want to explain the wage depend on whether you're female or male. Okay, so that is what we do. The second one, as I said, is you don't want to look at the wage, total wage per week by itself, but you want to normalize it by how many hours person work, right? Because men usually work longer than female, right? So you have to, it's called W. It's done. And you want to look at the summary statistics, okay? What we do is they group by male or female. You look at the wages and describe means give the summary statistics. Okay, so that's how you get all this thing. So let's copy and run. Okay. So that's what we see, right? For female, how many of them was the mean and standard deviation, right? You can notice that female is making $20 based on data here, right? And the male is making $24, right? This SD, mean, max, and so on and so forth, right? And one interesting thing you will see here is for the max is a little bit crazy, right? Some man is making like, wow, almost 3,000 US dollar per hour. And man is, some woman, the maximum woman can make is like 1,000 US dollar per hour. Okay. But anyway, they are all huge number. And compared to this, okay. Now we are data with this, then we can continue our analysis. Okay. We want to run a regression. Okay. We want to use this, whether you are female or male, to explain the wages, right? And do note that the female now is 0 to and 1, right? So for the male, you don't have this guy, right? 0. And the female, you have this guy, right? So when we take log of the wage, it's like how many percentage man is making, look at the beta, right? Because the female can only be 0 to 1, okay? And if beta is negative, as we would expect, will be the percentage change for male to female, okay? So that would be the idea. Now to run the regression, because it's a simple regression, we don't control anything else. So we need to restrict the data to be more meaningful, to be comparable, right? You can't compare male and female if they do different jobs, right? Maybe men are doing soldier, right? Doing some very dangerous job, right? Woman may be doing the back office, right? So we can't really compare. Or man doing some different job, right? Maybe that would be different. So that's what we're doing is we try to focus on the job that pay a lot, right? So there are two types of job that pay a lot. One is ITM, right? That's computer science. That's what you're doing, right? And probably that's why you're here, right? The second is marketing, right? That's why you do ITM. The M is paying as well, right? So IT and M, so basically, right? And let's run the regression. Okay. And we use robust SE. Okay. So first to do is to take a log because we care about the log. Okay. We don't care about wage itself because we want to look at the percentage change. Okay. It's not about the absolute number we care, but rather percentage. Now the next thing is to look at the job. And according to the data menu, as long as the occupation is between some number 1005 and 1240, then it's a computer science. It's a lot of jobs, but it's a 4-digit code that decide what the job there. But we just keep it, and then LOC means we select those observations. So now we are focusing on not wages, and we look at the CS, the computer science jobs, right? Now we're done, right? Of course, probably you want to look at the describe it first and see what's going on, right? And there's a lot, right? So probably you want to, let's see, what do I do? They don't do that, but we can do that. We can group by and describe, right? Maybe more fun to do that first, right? Okay, maybe we group by this. More fun to see it before we run the regression, right? Look at this, okay? And see in terms of log, right? Men are actually and women are different in terms of number, but these are much closer, right? The number, the quantitative log, right? But if you don't use the log ratio, use the raw wages, right? Look at W. Then I think that will be slightly more different. Okay. Okay. So let us see this. Okay. Now the next thing we do, okay, is to actually run the regression. Okay, we use the formula API. We just run the log wages over the female, right? So that's run it and then we print the summary there. This, okay. And then we print the summary and run the regression and see what do we have. So this is the regression, okay. And now look at the coefficient. So women make 40% less. If you control the occupation, much less. And look at the p-value here is the female coefficient, the p-value is like close to 0, right? That's okay. And this interval doesn't include 0, right? So this is a valid. So the 14% is valid difference, okay? So this what we discover is, at least in the IT, okay, data is so women are earning 14% less, but that is 2014, okay, in the US. I'm pretty sure that now the coefficient is positive. Women are making more in IT. That's my guess, but maybe wrong, but I don't have data, so you can take a look. But don't feel bad if you are female in our class. I don't think there's a gap right now. This is 2014. It's like 10 years ago, right? I think now it's already disappeared, the gap. But that's what we have, okay? So that's what he said, right? Because the beta is a percentage, right? There's a lot wages, so 14% less. And this is our best guess. It can be women usually can make 18% or 11% less in the data, right? Or the best guess is 14, but it can be anywhere. We believe most likely anywhere between 11 and 18%. Okay. And there's a gap there because it's not zero. At least in the computer science, there's a gap. Is that okay? Right. That's how we use the data, right? This is the estimation. This is hypothesis testing, right? These two things we have done. Now the next is focus on marketing. Okay. The marketing, the code is 735. Okay. So we subset the data, right, using the LOC command. So let's do that as well. And again, I guess we should look at the waste group first to have some fun on what they're looking, right? So we just subset the data. Unexpected indent. Okay, once we did that, we just look at the female and male raw wages different. In this case, actually women are making more if you look at the max people, right? But you look at 75 or median, actually women actually make less, right? So the top woman make more than top man, but middle man is making more than middle woman, and bad man is making more than bad woman. Okay, that is what the data is. Okay, so let's see whether we have something fun from the data. Okay, now again with the regression the same, right? Because the only difference in this guy, right, the MKT only, right? Everything the same. Okay, so let's run this regression. Right, there's nothing new, same as before, right? Because this is CS, but now we have the MKT, right? The regression 2 there, I print that out. It's that no nicer. So that is the model. Now, the coefficient is 11%, right? So we will predict the best estimate. Women make 11% less than men, but p-value is more than 5%. So we can't do much because you can see this includes 0, right? So based on the marketing, I can't say men are making more or making less. I can't tell. At least from the current data. At least if you use 5%, no. If you use 10%, yes, right? But as I said, we use 5% as a usual point, so we can't establish. Okay. So in the IT 10 years ago, men and women are making different salary, but marketing, no. Okay. At least probably because very good woman, the best woman are making a lot compared to men, right? So that is one of the reasons. Now, as this is we have said already, right? The CI includes 0, okay, and the p-value is 10%, right? 6%, right? So we can't do too much, okay? And how do you do, right? You want to collect more data, right? That's the only thing you can do, right? Otherwise, I mean, you just said we can't use the model, right? Now, the next is to use the Stark laser to combine the two things. I think this, you know what I've been doing based on the last set of slides, right? So it just combine the two regression and we write the order and then we name the coefficient. So I'm not going to explain this part because I guess this is a little bit too trivial. So that's what we create. And what I want to draw your attention on is the star. That's why they call star glazer. Look in the star. And you can see when you have 3 star, which means that the p-value is less than 0.1, 99%. And 2 star is what we're looking for in general, right? As long as 2 star, then we're done. Okay. But unfortunately, we only have 1 star for the second regression. So unfortunately, we can't say any wage gap for gender for marketing, but we can say there's a wage gap 10 years ago for the ITT industry. Okay? So that's why people looking for star. Okay. Is that okay? Now this is the output we have already. So what remains is to do is what we said in the beginning, right? Once we establish the model is useful, okay, we only do the following step after we say the betas are not 0, okay? Only if you have multiple stars, we can start doing following. We will now give you we can use the model, so the model can be used for prediction, okay? And the model itself offers the way to predict, right? But it's not the best, right? Because we want to know the range, right? Remember, let's see the typhoon again, right? We have a solid line, the data. If the observatory gives us only the dotted line, then it's not very satisfactory, right? Because the dotted line is on average, this is correct, right? Because it's what we call unbiased estimate, right? It's on average, is a correct path, which means that 50% is wrong, 50% is correct, right? Then I want to know how wrong it can be, right? And the yellow tells us that with very large confidence, which is 95%, is within the yellow one, right? So that means that if you're the boat, you're driving a boat, you're a fisherman, you should avoid the yellow area, right? When you yellow area, then you run away, right? So that would be the idea. Is that clear what we're doing? Okay. So now what we're going to do is to first figure out this is our model. We need to come up with the standard error and times 2, then you can do that, right? But of course, there's a formula for that, but we don't bother with the data, right? We will be using a Python code there. This is the data there. The code is what we call .get underscore prediction. Okay, that will give us the prediction, right? And after that, we will call the dot confidence interval. Okay, so that will give us the result. Okay, once we predict, we get prediction, and then we will use the confidence interval to give us what we want. Okay. This is the key. This is the key thing there. I should yellow it. Right? Okay. This is the key step. Okay. But I'll do with you because I think we need to show you how we work on that. 5% means that 95% interval. Okay. So let me do it one by one and show you this graph. Okay. So first, I think this is no need to explain. This is the data. I add X, I run the regression. This is the thing, right? So I think this part require no further explanation. Okay. And this X is I run the regression, right? And if you like, I have to use the covariance type XG3 if you want. It's up to you whether you want to do it, but let's do that. Okay. And this is the model. I hope everyone. The first thing to establish is, okay, the coefficient the p-value is less than 5%, right? So we can start doing something. If p-value is not less than 5%, then we just go home, right? This is rubbish, not do anything. We have to ask them our model. Now we establish the model useful, then we can go further to use the model, okay? How to use the model is to create something like this, okay? So what we're doing. And what we're doing is, okay, we would look at, we would plot many value, okay? We have to tell me what is x they are, okay? So here is slightly more complicated. Sorry, but this is necessary for our purpose. Is we have to create bunch of x from the smallest of x, x dot mean, to the x dot max is the maximum of x, and line space, linear space means that I create 100 data points from minimum x to maximum x. Okay, why I do that? Because based on the model, I need to have 100 number of data point. Okay, let me write down, because I look at your face. Many of you are still confused, so let me say the following. So what I'm doing is the following. Now we have the data. Let me do it. Okay, so this is the scatter plot, right? So let me do that. Okay, and suppose we have the data here. The data we have like this, right? We have some data here, some data there. Okay, and now what we are doing is, okay, the data would, the Python would give us this regression, right? And we have shown that this regression is a valid regression because p-value is less than 5%, right? I think yes, right? And then we're happy, right? And what next is, okay, we want to use it, okay? How do we do that? What we're going to do is look at the minimum data, mean, sorry for that fake, mean, right? Look at the max. I shouldn't use this crazy pen. Okay, and I divide it into 100 data point here. Okay, and based on this, I would predict what's the y there, right? But this is already the best I can predict, right? This is the mean, right? But now what I want to do is to look at the confidence interval for each point, because each point is different. So indeed, you can imagine our cell is here, and there's a normal curve here. All right, there's normal is here. There's a bell here. You look at the 95%, right? It's here, right? And I look at this value and this value. Okay, this gives us a band. We do it for 100 value there. Then at the end of the day, you will see the band something like this. Okay, this is the thing we are going to do. Okay, for each point, we will tell me the interval, right? Because interval will depend on the data point. Is that clear? I hope it's clear what we're doing. So what we are trying to show, okay, is like this. Okay, I have the data, I add a constant to it. Okay, and then I predict means that I look at all the 100 points on the line. Okay, and this prediction, the mean, will give us the value of the predict, the y line. Okay, and this function will enable us to calculate the range, the maximum, the minimum. Okay, the first item is the lower, the second item is the higher. Okay, so let me copy this code, then you will, let me see, I can convince you this. Okay, let me do one by one to convince you this is something that we need. Okay, so let me first do this guy. Okay, what it's doing, I told you that you call when you construct this, let me show you this guy. What is it? You create the max and the mean, right? You start from 1, the minimum. The maximum is 7. You basically divide them into 100 data point there, okay? And then this one will add a 1 there, and then you predict, okay? Yeah. And let me stop here because I want to show you what it is here first. Okay. You can see they will predict for every point, they will predict. Okay. And observation false because I don't want the original observation. So that's why. Let's make it simpler. Okay. So if I do that, that means that the first element is the lower bound, the element is upper bound. Okay. So once I did that, then I can draw a graph. Okay. For plotting, it's slightly a little bit complicated, but shouldn't be too difficult. Okay. The first is scatter plot. I think we know that very well. The only new thing is I have a label because I want to have a legend. You don't have this, whether this or not is an issue. And I plot the line, right? Because this is the plot. Okay. And what I do is I want to like the typhoon graph. I want to fill, okay, the value x. Okay. I want to fill the lower bound, upper bound. I fill in between using the color grade. I use alpha equal to 0.3, and I name it confidence level, and so on and so forth, right? The rest will be simple. Do note that because of the typo or the autocorrect function, there's some issue when you copy. You make sure that this thing is there. Okay. So this should be there, should be fine. So I think since we like yellow, then let's change the color to yellow. I guess that would make me happier. This is it. So you see this is the graph we want, right? So this is a line, okay? And this is the range, okay? That means that your model is not just a line, right? Indeed, your model is slightly more complicated, right? Because it's model, and this is how the band of your model, right? So you give more information about your model, right? Is that clear what we're doing, right? Because this is what Hong Kong Observatory is doing, right? They tell you that this is where the typhoon go, right? And this is the range that the possible one. Okay, is that clear? Is that okay? If that is okay, we go to the very last one. Okay, for this part, we have a break. Now, once we have this, we want to run another regression, okay, and look at how wages change over time, okay, and we focus on marketing occupation, okay. Instead of the female, we want to run wages over age, right? And what does that mean here is each year, how your wage change in percentage, which means the beta is the raise percentage, right? 1%, 2%, 3%, 4%, right? This is the idea. And we use robust SE, okay? And just fit this model. I think that's something we know very well, okay? And I print the summary there. Yes, I need to do that. Not nicer. That's it. Do I need that? In fact, yeah, print is better. So we have a nice summary here, right? If you run this, right, you will see our salary in terms of marketing, is rising by 1.3% per year, right, on average. And this p-value is, makes sense, right? Is 0, okay? And it can be 0.8% to almost 2% per year, right? At least for the marketing people, right, over time. Okay, this is what the model tells you, okay? And of course, this is what we have here, okay? But what we want, you can do star glazer, which I'm not going to do it. But I guess the main thing is we want to actually plot the data, okay? And to plot the data, we'll use what we call, slightly more complicated. We will do what we call doc summary underscore frame. Maybe should I use this one? Maybe this one is easier. Same slide. So use this one, it's better. Just forget about that slide, it's easier, okay? So you would do the regression 3, use the doc underscore get prediction, okay? And then doc data frame. And you don't need to tell the data what you're predicting. The reason being that they will get the prediction for all existing X. Okay. So we have that. But let's show you what do they give you. You will see what do we mean by this function there. Okay. If you do that, let me do the predict CI. Okay. So you see what it's doing right now. So you will see what it's doing is, okay, it will tell you the mean prediction of the model, and say the observation of this is the Y, this is standard error, right? And the interval there, right? That is what it's doing, right? The mean. We'll talk about the OBS this time, but these are the number that we have done. So what we do is we combine that with our original data set with MKT, okay? That means that we'll attach a prediction to the original data, right? So this is the predict CI will be the data that contain all the prediction information, and I want to combine them with the original data. Why? I want to draw a graph. Okay. So that's what I do. Okay. Remember, when they've joined, they're based on the index. So now what I do is I combine them, then I do the drawing. Okay. That is how. So let me do it, and I show it DF was DF1, then you will see what it is, okay? So once I combine data, you will see the original data, okay? And at the end, you tell you the wages, the mean, the prediction of this, okay? And this is the error, right? So this is the Y, right? The Y is this guy, right? This is my prediction, right? And this common interval. So now we want to plot the graph we have here, but as the book would suggest, to make the graph nicer, we only keep the data where the log wage is more than 2, not too low and not too high, okay? Keep the mid-level of the wages. And I sort the data based on age, right? Because we are plotting things based on age, right? So that is what I'm trying to do. So this would be wage, not age, sorry, it's the typo, wage. Okay. Wage. We keep the wages and sort the data based on age, okay? And then we are ready to draw, okay? So because I want to draw X as age, Y as wage increment, right? And this is y, and y predict is the one predict from the data, the mean, and ci lower and upper will be the interval we are guessing, right? So that would be the model. Okay, and once we have that, then we do the same plotting function, then we're done. All right. So once we do that, I'm done. So plot like this, right? The red one is the mean. The dotted one will be the one that actually you predict. It's around this range, right? So it's pretty much a nice one, right? So this is how you predict the how earning grow over the years. Okay. Is that okay? There's the graph there. Is that okay? I think I should break for 15 minutes because I think you guys are pretty much exhausted. The break of 15 minutes, and then we will resume at 8:35. Last session today. After this, we can talk over. But it's good. After this, we'll talk about multiple regression. Then that's probably end of the regression stuff. Probably next we talk about machine. I think we talk about something machine learning already, or no, or something related to that, right? I think lesson 6 is yeah, lesson 6 we talk about probability. Then we will do some prediction and machine learning. But so let's break, okay? And then we talk after the break. No bothering you to put in the phone. We will have a question. The power. 那边这个 B.B.A、B.W.S，但是还有检查什么 skewness，这上面都是。啊，嗯，这个这个没有讲，在录的下面，我可以自己找。一般来说，我点的很小，有 ICM 的，有后面 uh, before we continue, we talk something that make you a little bit awake, right? Because you guys are very tired. So just to show you something, I mean, I look at, I show you my last year sample question for the exam. Not the exam paper, but the sample question, but they will be very close to the exam. But I later released the true question last year. Okay, but this is the sample question that I released last year. But actually, that turned out to be very similar to the style. So this is the sample question I gave last year before the exam, but I will give the true question last year. Okay, they will be something like this. Okay, so because some of you asked me, we don't allow you to bring your computer, then why ask cook in the exam? So the way we do is the following. So I will just, this is a good question because now you know what do I mean by the code, right? So basically what I do is I will give you the code, okay, like this. Okay, this is the code, right? I hope you understand what's going on. Now, otherwise you were sleeping, right? You should know what the code is, right? This is regression, and this gives you data, this output, and then what asks is like this, right? You have some open question, ask you to define what it's doing, right? And then based on the output, you tell me and how to use it, right? Fair? Something shouldn't be something super complicated, right? You don't need to worry about the code because I'm not asking the code. You have to know what the code is and going on, right? So you don't have to write the code. And the other question would be something, the next question, the example I gave is like this. Later you will see this regression tree here. There's a data, fit this model, a tree model. You can imagine there's a bin scatter, but it's more complicated bin scatter, right? When x is less than 1.5, this is the value, this is 4, it's like bin scatter, but then ask you what the prediction and explain somewhat like along this line. Of course, I will release the real question when we close to the end of the class, right? The course, but that would be something like that. Okay. I hope make you feel a little bit relaxed because right, we don't really ask you to do the coding. Because that should be supposed to be an assignment in your project. So what I do is at the end combine the code, the output, ask you how to use it. That's it. That's what I'm trying to do. Okay. But maybe at the end, after this we will do the multiple regression, which again is not something complicated. So the last one to talk about is the slightly advanced topic. So this is a little bit not that easy if you don't understand what's going on here. Okay. So what the confidence interval, what we have just seen, is predicting the average value. Okay. What do I mean by that is I need a slightly little bit explanation there. So when I write the interval CI, okay, I actually not saying the individual value. Okay, what I meant is suppose this is x. Okay, x here, and this is the y, right? And what we do is we have on average is there, right? But it can be here, 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 here. Many possible, right? Can be any number, right? And then I care about the average of this value that give us the CI. Okay, not particular value, but on average where they are. Okay, if I predict average value given x, this is what we have. But if we predict individual value, okay, not just a particular value, it can have more variation. So the formula is slightly more complicated. Okay, not predicting the average, but individual value. Okay, and that require us to have a little bit more complicated formula there is if you look at the formula, there's a one more one here. It comes from the fact that not look at the average, there's another additional variation goes on. But I think you've learned the undergrad. Okay. But anyway, we don't care about the formula. And what we do is the Python. I think that is more important. The Python we have is a mean CI, but the observation CI is the thing we care. So if you care about individual value rather than average value, that with the model, okay? And I guess I should put the, I look at your face, seems to be, you guys are, looks like a little bit confused. So I think I decided that now is, I would put this to technical, so you can safely log PI if you don't get it. But if you learn the undergrad, that would be something simple. But I just, I think that we should skip this part as a technical part because I figure out that maybe you guys are not, maybe a little bit too technical for you guys. Okay, but I just run the code and show you what we have. Okay, I hope that would at least tell you what's going on there. Okay. So in this particular example, you can see our model like this, the red one, right? And if you look at the possible line is actually somewhere here, right? But you look at individual value, it can be somewhere along the yellow one, right? So that means that individual value can almost like way much bigger than the average value, right? So that means that if the formula like this, if I ask a guy, pick up a guy who is 40 years old, okay? If I pick many of them, on average will be somewhere in this small region. But if I take particular guy, it can be here, can be here, can be here, and be here. So one guy can be much more variation, okay? But I don't want to confuse you, so I just basically, you can forget about the PI because I guess you don't use it that often, okay? The CI is the thing that we care, right? On average, what it looks like. Right? I think that might be an easier way to solve this problem is to consider this technical because very often I don't think I use PI that often. So CI is more often because we care about average rather individual value, right? So usually if you look at textbook, PI is referred to confidence interval for individual value, and CI is confidence for average value. So, but I guess I don't want, I look at your face, okay? I guess going to individual value way, go beyond our brain for the tired moment. So maybe we just skip this part. Okay. So there are two things to mention a little bit is the regression, is it going to work, right? And in particular, if you look at let me look at this data, maybe more fun to mention that, right? Because that is more. So if you recall the last example that we talked at the end, right? Run the regression, okay? The thing is, do we have much confidence in this one, this part? Especially the fact that there are very few data here, right? So that we call extrapolation, or we have what we call this very few data there. We usually don't attach too much confidence to those, right? If within the data range, then this model will be very believable, right? So you have to be careful and try to extend the data, right? Because we always what we're doing is extending our knowledge from the data help us to extend the knowledge from what we know to what we don't know, right? But if our step is too big, then probably we are working in the area that we don't know too much. Then the prediction may be problematic, right? Especially talk about stock price, right? And if we are using the historical data to predict the future, then usually it's rather tough, right? It's not clear whether the past is a good indicator of the future, right? But sometimes the best we can know, right? You can't say too much, okay? But that's what we have, right? So the next part is eventually we come to this chapter 10, which means that this is the model that we actually will use in practice. Okay. So far, the model is just illustration. Okay. I'll tell the basic thing. This is the model we start from chapter 10 is the thing that we actually use. Okay. And from now on, this is the model that you use in practice. We use in our data analysis. We use in a project. So don't worry. In terms of programming, that is very similar. The idea is following. You want to explain why by many variable. Here we have k variable, x1, x2, up to xk. Okay. And again, we want to minimize the vertical distance. There's nothing new there, right? So what do we have to do? Okay. If you use matrix algebra, the coefficient can be found in this form, okay? And I don't think we care because we have computer, right? So everything can be found, right? Using computer anyway. So, and the standard error also can find by computer, so we don't care about this again, okay? So the good part is let's run regression, right? And in the last class, sorry, in the previous chapter, we saw two things. One is being a male or female affect your wage growth, right? There is a 20% difference between female and male. And also how old you are or how experienced you are affect your wage. So we naturally ask the following question: how your wage is determined by your gender and your experience. Right? This is what we want. Okay, of course, you can include many things. Well, right? Maybe which occupation you are, maybe many things, right? But that is the model we want to look at. So again, we do the filtering data to ages, and here we have to restrict the hour working more than 20 hours, and only include employed. And here we have grade 92 means that they are 44 means they have college above. Okay, so that is our model. Okay, again, we download the data here. Okay, we download our data. Okay. I think that's don't require me to explain. Okay, and this is the same as before, right? We have the female and then hours, and this is log wages that we're interested in. So this is the data we know already. This is a code we're not going to explain. The next step is more important is we have to fill the data using ROC command. Hour more than 20 hours. You have actually are working more than 0. Age is between 24 and 24 to 64, and the grade is 44. Or 24? Is it something? Well, let me see. 24, I said. Should be 15. Anyway, let me change the code because should be 15. So this should be 15. I don't know why I have 24 here. Oh, I see. So A should be 15 because they finished college. So there should be 24 more. Sorry. I think the original slide is not correct. Not between 15, it's between 24. So once we figure that out, they run the regression. Okay. And let me do the other rate run. I think I don't like what we are doing. So let me change a little bit the regression. So I want to run this. So I'll make a slight changes. Sorry. I think that would be better. Okay. The first regression I run is the female, which already run, and age. I run the age plus female. I think this is better. I want to look at this. Okay. Now, once I run the regression, I don't have the result yet, right? So I can print the summary and read it, but rather I would use the star glazer to help me to look at the final answer. So let me do it, and I stop a little bit so that you can work it out. And I don't need this line. Yes. Oh, sorry. I should do the MP dot where. So there's some slight changes to the female. I should use the MP where. I don't know why. I think slide is not updated, but this is what I have. And I change it to female, age, and the last one is this one. Okay. Once I run this, I have the following. So you can see they all are 3 stars. So it's good. Everything is nice, so there's no problem. This, again, from the data, we know women earn 20% less. And you get older, you get almost 1% increment for each year. Now, if you have female and age, okay, then this change a little bit. It's a 0.7% increment per year. And this female actually a little bit reduced. Okay. So that means that on average, there are more women retire earlier. Okay. So that's why you see this kind of relationship. Usually you have a long list of regression and you check all the star, and then that's what we do. Okay. So this is the thing that suppose you want to have something like h squared, you would do the similar thing, right? Suppose I have something like the following. If you want to have fun, right? Maybe I have CP as, right, h squared, right? CPS h star 2, right? I have this one. And then I can have another equation that allow me to have h squared. Okay. Question 4. Right. I forget about this nonsense. Doesn't really matter anyway. Right. Just run about it, and then run it. right? Then you have more, right? And then you can add as many as you want, and then you run the regression. That's usually what you do, right? So you add many row as you think that would fit, and then you continue to do as many as you want, okay? And of course, at this stage, you are the one to decide what is in X. That is human regression, right? Later, when we want machine learning, it's the machine decide which is there, okay? And now you are the manager, you decide. Soon, or you have manager decide, right? But sooner, later, then you learn a model that will tell us which should be there, which is not. Okay. That would be, we will learn that I think 2 weeks later, we'll have a lyso regression. We'll start with a lot of variable, as many as we want, we cut. That is something we do. Okay. Oh, actually, it's here. Ph.D. already. I think I did my part too early. Okay, a square is here, and star glaze already there, so we're already done with this part. So is that okay? So far, is it okay? Now we want to have some more fun. Okay, is to talk about categorical data. Okay, and do I have the example here? No, I don't. But I think what I want to do is to talk about what we call the interaction variable here. Okay, is we have if we give example, it is this is too technical. So this one. Okay. So we have a regression, wages, try to be explained by female, age, okay? And now we have something multiply. So we ask, what is this, okay? Because we want to say, okay, your wage rate will be depend on your female or male, also depend on how old you are, how experienced you are. But this allow the idea that men and women and grow in a different wage path, right? Maybe women go faster, maybe women go slower, I don't know. Okay, if you allow that, you have a different path. Okay, so this called interaction is to multiply. Okay, because it is like, actually this is come from the mathematics problem, right? If you have x1, x2, you can involve all the polynomial that will mimic every function you want, right? So interaction is you would just multiply them as many as you want, and you run the regression, then you're done, right? Because any function can be mimicked by, if the continuous can be mimicked by polynomial, right? So you have x1 and x2, and you multiply them, then you're done, right? You take a square, any combination of the square term, you can also do that. Okay, so that's what we want to say. And later we'll show the regression result that actually negative. So that means that female not only have lower wages, they also have slower wage growth. Okay, so that is the reason probably why men and women are making different wages. Okay, not only they have lower starting salary, they actually may have different. And the good thing about the SMF in the Python is that you are allowed to use multiply in order to create another variable. And there are two, okay, there's a little bit different here is you would run 5 and 6. We use the called query Python code. We said I restrict myself to male, run the regression. The first one is I restrict myself to female, I run the regression. Okay. So this is the data. Okay. So that is the idea. Okay. So let me run this. Okay. This is my last code to run because I guess we are already faster than other class. So I don't want to be too fast compared to other class. Okay. Let me run this one, then I'm done. Okay, this is the last code I'm running for today. Okay. So what here showing is I have two model here. Okay. This is the regression on only women, regret on the age. Okay. So women go each year, their wages go by 0.6% on average. Men is almost like 0.9%, almost 1% per year. Right? And if you look at look at this regression, right? Age, men go by 9%, right? But woman is actually this plus this, is this guy, right? No, sorry, this give it this guy, right? Because age, female age, so if you're female, you add up these two, right? If you're male, it's this guy. Okay, so let me do it again. So if you combine this regression, it's just same as separating into two equations. So this same as this guy, okay, and this and this, give it this guy. Is that okay? Because how age changes, right? Men and women are different, right? Men go faster. So that's why the interact means that female grows 0.3% slower. Okay. And that is the two things, right? So we establish, using the regression, we establish two facts, if you want to say. One is women are paid less at the beginning, right? Second, no matter which age you look at, women earn less. Second is when each year, your wage increment, woman is going slower. Okay, so this is what this data tells you. Okay. Is that clear what we're looking? Because this interaction is very important in many settings, right? Because you would a lot of groupings, right? You interact and see each grouping will make a difference, because this is the main tools of a lot of time that you would do, right? You group things in the group and see how group changes the outcome, right? And right, because you do a lot of why is the how people spend in your website, or how much time they do it, or the outcome variable, right? You want to look at this by looking at how they behave, right? You say implement something new, okay? Something new can be female. It's a switch on and off, right? And this on and off can be useful, but you want to know how useful they are, right? Look at interact with, say, age or any other thing, right? So that is how you will use it, right? Imagine female is a feature in your website, right? Age may be different, how wealthy the customer is, right? Then maybe you show that your website, your new feature actually useful, but maybe only useful for customer who have spent a lot of time there or other way around, right? So that can be done in this way. So the interaction is something that you often use, okay? Because it's may not be linear, but some interaction, right? They combine effect. Itself with no effect, right? It's the ANOVA, the interaction, right? Maybe you implement this new feature, has no impact on the website. Other feature B has no impact. But A and B together have impact, right? So that can happen, right? So that is how you do interaction. Okay. So I guess I should stop here because I think we are faster than we need, and some of you actually asked me to end earlier, right? And since we overtime a lot of time, so I think it's okay we end today like here. Okay. Just make sure that you are trying to do your homework, right? Because our homework is due 23rd, right? So it's like next Wednesday is the due date, the homework, okay? 10 questions. And quiz 2 is also due in 2 weeks' time, okay? So take the time to do those. Quiz 2, just do it, you get all the credit, okay? Just do it. If you don't do it, I can't help you, right? Just do something. And assignment 1 should be easy, right? Some of you said you fit in the ChatGPT, you're done. But I recommend you actually do it, okay? It's not something complicated, right? It's basically you understand the PPT, then you can use it. Okay? But anyway, I will see you next Friday. So enjoy. I'm sorry you have makeup class, but we don't have, we shouldn't have, because I don't think typhoon is going to kill our class. See you next time. I stay around to answer any question you might have. Bye-bye.